So, hello students, good evening. So, we are going to learn about some questions from the mechanical properties of fluids basically, right? So, here you can see that there are different questions here. So, we are going to solve all of this, right? So, the first question you can observe that what is given a girl, a 50 kg girl, that is the mass of the girl is given, right? Wearing high heel shoes, balances on a single heel, right? So, she is trying to balance her weight on the single wheel. The heel the heel is actually circular with a diameter is there, right? So diameter of the heel is given, right? So if suppose heel is a circular heel, right? So the diameter of the heel is given, which is actually d is given, that is 1 centimeter, right? What is the pressure exerted by the heel on the horizontal floor? Now they are asking what is the pressure exerted by it, right? So what is the mass of the girl? You can see here the mass of the girl is given, right? So the mass of the girl, if I'm writing it here, right? So mass is given, that is 50 kg, right? How much it is given? 50 kg. Got a point. So you can observe that there will be a weight of the girl also. So because we know whenever we need to find out the pressure, right? Basically, this is the heel, right? So heel cross section area is like that. So obviously it will be lying on some surface, right? So this is the surface which is there. Now mass is given and we know weight will be what? Weight is equal to m into g formula, right? So we will going to see. So 50 into 9.8, let's keep 9.8 here because 10 they have not given to us, right? 9.8 and you will get it in the form of Newton. Right? So let's keep it like that. Because later on we are going to solve it, right? After there's asking us pressure. So we know pressure is equal to force per unit area, right? So weight force will be the weight here and per unit area. So for finding the area, we need the radius, right? Because diameter is given. So what will be the radius? So the radius will be that is 0.5 into 10 to the power minus 2. You will ask me why minus 2 because it should be converted into meter here, right? So you can observe that. So it will get 50 into 9.8, right? By again, if you divide it, right? Again, what you will get it is pi r square. R is what? R is 0.5. 0.5 I will write 5 into 10 to the power minus 3 students, so that the point will not be there and here it will be helping me to solve this at the last, right? Now after that you can observe that, so if I'm doing it, so 15 to 5, 15 to 9.8, right? And here pi I can take 3.14 and next it will be 25 into 10 to the power minus 6, right? So if you solve it more, you are going to get around 6.24 into 10 to the power 6 Pascal. So see, answers already you are going to get in the exam also, but just the procedure is very much important, right? So this is your pressure, you got it correct. So 6.24 into 10 to the power 6 Pascal. Now the next question is, I hope you can see this question here, right? So what is the next question? The next question is Torricelli barometer used mercury and Pascal duplicated it using French wine of density 984 kg per meter cube. Determine the height of the wine column for normal atmospheric pressure. So before going to the question, right? So you must have the idea that what Torricelli has done, right? So basically Torricelli has done what I have told you about a inverted tube, right? So Torricelli has taken what? Torricelli has taken mercury in a tube and he has just reversed it, right? Basically, what he has done, he has just reversed it, basically, right? So after reversing it, you will observe that what happened. So while reversing, first he filled it, right? So this is actually the inverted tube which you kept it here in this mercury beaker, right? So this beaker is also having the mercury in that. So what he has done, he has just put, so first suppose this is the tube, right? He is having the tube. So let me draw the tube at the first, right? So what he has done, so you can observe that first he has drawn this tube, right? So he has taken this tube. In that tube he put the mercury at the first, right? After putting it, so there will be no air, right? Then we put our fingers here and we close it and we just reverse it. So while reversing it, when we will put it, you will see that you are going to get like this, right? So here in this case you are going to see that mercury will reach up to here, up to this level, right? Now you will tell me that why this is blank, because and this blank is having a vacuum here because we have not kept any air in that, right? And since it is vacuum, but you can see here this pressure will be, suppose it is zero, right? And here there will be a pressure at the same level, and that pressure will be known as atmospheric pressure, right? Because this beaker is near to the atmosphere, correct? So what we were getting, how we got it in the Torricelli barometer, we got it Torricelli barometer, we took it PATM, remember? And PATM we have taken, and PATM rho into G into H we have taken, right? So in that what we got, in that we got the value of the height there, right? So the height we have got it in that Torricelli barometer, got the point? So after that we are going to do the same thing with here also, right? So here what they have actually asked, they have asked us about the height, right? How much height the French wine will go, right? For doing this, what technique we can use it here, if you observe, right? So we can use the same technique, right? So in Torricelli, did you remember that the height was actually 76 centimeter? So in Torricelli barometer, we have got the height that was 76 centimeter, correct? But now, so they are telling you that, so based on that, we got height. So height was actually PATM, right? So P atmospheric by rho g we have done, right? So in that we got the height from there, right? And we have got the height in after looking at the looking at the Torricelli barometer also. So we got the required height at that time. So from there we got the P atmospheric pressure value also, correct? Now they are telling that instead of mercury, Pascal has duplicated this experiment. So if the duplication has been done by Pascal, right? Duplication, so if duplication has been done by the Pascal, so there what Pascal has used a French wine of density. So the density of the French wine is given, and that is 984 kg per meter cube, right? That is mass by volume, right? After it, you can observe it here, determine the height of the wine. So how we will find the height of the wine? We know height of the wine will be, that is P ATM by rho into G. Got the point? So now you can observe that. So what is the height? So P atmospheric pressure we know that is the value is 1.013 into 10 to the power 5 Pascal, right? So you can take it 1 also, but mostly we take it 1.013 into 10 to the power 5 Pascal is there for atmospheric pressure, right? So which we call it 1 bar, right? And here it will observe that you are going to get, that is 984 we are going to get, right? So basically when we are going to get it around here 984, right? 984, and we need to put what? We need to put here 9.8. So if you divide it, we are going to get the value around 10.5 meter. That is how much? 10.5 meter, right? So before that what we have got, before that we have got it around 76 centimeter was there, right? 76 centimeter, and in this case we are getting 10.5 meter, right? So now you understood that, because this is why, because see, the more the density, the pack it will be, right? Pack structure it will be. That's the reason in this structure we have took the mercury, right? Torricelli has took the mercury. What is the reason? Because mercury is more dense, right? So if mercury is more dense, the height was very less in mercury because the density was more in this case. But now we have decreased the density. So we have decreased the density, everything remains same. So obviously height has to be increased, right? That is the reason we are getting 10.5 meter. I hope you understood this one, right? Next question. So you can see here, basically this is a question, right? So what is written in this? You can observe a vertical offshore structure is built to withstand a maximum stress rise. So here a vertical offshore structure is going, offshore means, shore means the region near to the ocean, right? So if this is the ocean, so the nearby region will be called the shore, right? So here basically there will be two concepts. One is onshore. Onshore means near on the land you are basically doing, and offshore means just near to it on the water you are doing it, right? So here basically offshore they are saying, so we need to keep it in water here, right? So now what they are saying, a offshore structure is built to withstand a maximum stress of. So here the maximum stress is given, right? So what is given? The pressure P maximum is given. That is 10 to the power 9 Pascal. Means it is made to get. So that is the maximum limit, right? Because we can't give it more. If we give it more, you will observe that it is going to ultimately what? It is going to break it, right? Is the structure suitable for putting up on the top of a oil well in the ocean, right? Top of a oil well, because oil will be inside it, right? So top oil well will be there. So on the top of it can be put it, right? Put this structure. Basically, they are asking. Take the depth of the ocean to be roughly around the depth of the ocean. They are asking us to be roughly around 3 kilometers, right? So you can observe that since that means what the height will be 3 kilometer, and we know when we convert this 3 kilometer right to meter, you will get it around 3000 meter, right? 3000 meter is there. Now let's find what is the pressure, because see this structure will be not that much depth, because ocean height is very high, right? Means it is very much depth. So basically you will see that the structure will come around here, right? So that is the height here. Now you can observe that. So let's check whether it can withstand it not, right? So to check it, you'll find the pressure at that depth. So pressure because of the ocean, right? So what is the pressure because of the ocean? You will observe that we can find it by rho gh, right? So what is rho value we are going to put? So rho is 10 to the power 3, right? So basically 10 to the power 3. And now again you can observe that if rho is 10 to the power 3, it will be 9.8. And what is the height? Height is given, that is 3 into 10 to the power 3 into 10 to the power 3, not 9. 3 into 10 to the power 3, right? So after solving this, we are going to get it around 9, 8, 3 are 24, 4, 2, 9, 3 are 27, 28, 29, right? So we are going to get 2.94 and here 24, right? Just give me 1 second here. 8, 3 are 24. So 4 and 3, 27, right? 2, 7, 9, 27 and 2 was there. Just 1 second. I'm doing a mistake here. So 9, 3, 8, 3 are 24, 4, 2. 9 3 are 27, 29, right? So now we got correct 2.94 into 10 to the power 7 Pascal. We got it, right? So see, now compare these two values. So one value is 2.94 into 10 to the power 7 and one is 10 to the power 9. So obviously this P max is more, right? So therefore we can write here, therefore it is less than the maximum stress, right? So the structure is suitable. We can write what? Structure is suitable. Any doubt here? So after that, we can go to the next question, right? So next question is will be little bit tricky, right? So there are two parts of the same question here. So basically, what is the question here? They are saying you that a YouTube contain contain water and methyl spirit will be there, right? So basically, what is happening? So there is a YouTube, right? Let me make the YouTube just for your understanding. So this is basically the YouTube which is present here. It is saying you YouTube, don't think that the YouTube for movies or playing videos. No, that is not the YouTube. Basically, physics we deal with this type of YouTube, right? Contains water and methylated spirit separated by mercury. So see, mercury when we are keeping students, so mercury will be up to here. If suppose the mercury you can keep it up to here also, no issues, but mercury will be at the same level, right? Because inside that the mercury will be eventually distributed, right? So but I have drawn what? I have drawn mercury up to at this level. You can see here, this is my full mercury, right? Here mercury will be there. So now you can see here, and so here it contains, one side it is containing what? One side it is containing water, and here methylated spirit separated by mercury. The mercury column in the two arms are in the level with with 10 centimeter of water. So here water will be up to here, right? So water is what? Water is 10 centimeter, correct? And 12.5 centimeter, little bit more will be there, correct? So that is 12.5 centimeter of the spirit. What is the specific gravity of the spirit? They are asking you about the specific gravity. I hope you are aware of the specific gravity of that, right? Basically, you are aware of the specific gravity. Specific gravity of the spirit will be what? Basically, they are asking us to find specific. Specific, I told you, suppose this is the density of the spirit, right? So here, if you divide the density of the spirit, any substance, if you divide with the density of the water, the ratio, whatever you are going to get, that will be our specific gravity, right? Specific gravity. Now you can understand it here, students, right? So after that, from where we are going to get, right? So that means ultimately, what is our motto? Our motto is to get this, that is rho s by rho s by rho w we need to get, right? So this one is your water, right? So here this side is what? This side your density of water and this side your density of the spirit. Right? So now see, let's take at this level, because I told you whenever you need to do pressure question, always keep it in mind that you have to take some level, right? Let's take the same level, and we know same level, at same level pressure of liquids are same, right? So what we are going to get, so in this level you can going to observe that in both the sides, right? In first side you are going to get, that is what, rho, that is rho w into g into height is what, 10 centimeter, right? On right side you are going to get, that is rho of the spirit into g into height is 12.5. Now your question is, sir, if this are in centimeter, why we are not converting to meter? Because see, both the sides it is there, right? So ultimately if we do it also, it means the same, because anyway we can cut it up, and if we are doing in both the sides that are equal, right? So that will be of no use here, right? So now you can observe it here. So what we are going to get, we are going to get r rho s by rho w, right? So dg get cancelled, and we are going to get around 10 by 12.5, right? So 10 by 12.5, if you are going to do, it will come as 0.8. So this is what, this is the specific gravity of the spirit, right? So one part of the question is done. Again there is another part which is left out, right? So I have just added the same question in the same page here. Now see, they are saying that in the previous problem, they are saying you what, they are saying that in the previous problem, a 15 centimeter of water and spirit each are further poured into the respective arms of the tube, right? Respective arms means, if suppose earlier they were coming up to this much level, now we have added water, right? So this here we have added water of 25. Now why 25? Because earlier water was 10. Now we have added. So this part will be what, you can observe that. Suppose if you are telling, take any part, right? So here what they are taking, this mercury level there, right? So now they are saying that we have added, earlier 10 was there, now we have added more. So right, ultimately, so it will become what? It will become 25. So here they are taking the base not here, rather they are taking the base up to here. Means they are telling that down there is a mercury only, right? So this is the base they are taking. So here 25 centimeter, and this side earlier it was 12.5, now 15 centimeter again added more, so it becomes 27.5 centimeter, right? Now they're asking that what is the specific, what is the difference in the levels of mercury in the two arms, right? Difference in the levels of mercury in the two arms, basically, right? So here basically in the levels of the mercury, right? So now in that what we need to do, we need to find the height, right? Basically we are going to find out what, we are going to find out the height. So in this case we will observe that, right? So here basically what is the height difference, correct? So if you observe that there will be height difference, right? So now suppose this side, if you observe it here, pressure difference should be equal, right? If I'm taking at this level, so both the side the pressure difference should be same, right? So here you can observe that it will come up to this much level, right? Suppose I'm just taking an example, let's take an example of the YouTube, right? So here this is an YouTube, right? So you can observe that in the YouTube, what is going to happen, right? So basically, suppose there is a spirit, right? So basically, Mercury will try to get, ultimately see in the same point, right? Suppose here, if suppose this one is a water, right? Now water is here, up to here, water is there, right? So this level we know, you can see here, this level water is there. So it is 25 centimeter, right? Now you can observe that the spirit will go more up, right? Because see, if we take the same amount, right? Suppose we are taking at this water level, let's consider this water level, right? So if you take it at water level, it has to balance, right? So if we take only this much height, it will not balance, right? Got a point. So that is the reason we have taken the height difference here, right? This is the height difference. Now you can observe that because of this height difference, right? What we are going to get, because of this height difference, we have added two things more, right? Now see, so in that case here, so they see in the first you will observe there is a difference between these two questions. The first question is UTIP contains water and methylene spirit separated by mercury. The mercury columns in the two arm are in level with the 10 centimeter of water in one arm, and here 12.5 centimeter of spirit in the other arm, right? So this is what mercury column is leveling it. But now what they are saying you here, if 15 centimeter of water and spirit, they are not, they say that it has poured. Did they told you about the levels of mercury are the same? The answer is no. That's the reason they are asking the difference in the level. So difference in the level you can think from this diagram, right? There is a difference. So mercury in the first column will be this side and mercury in the second column will be up to this level, right? See this level, and mercury in the first will be up to this level. Getting the point? Why? Because this level, because you can see if you want to take up to here, right? So this will be the water column. Now here there will be speed column. So it needs some extra, right? So who will compensate this extra? It will be compensated by the mercury only, correct? So now what is the equations we are going to use, right? So we are going to use, suppose the height difference, they have kept it as h, right? So the height difference, they have kept it as what? They have kept it as h. So we'll take the pressure at the bottom of the two sides. Pressure at the bottom of the two sides must be equal, right? So what we are going to write? We are going to write pressure at bottom must be equal, right? BO bottom, BO double DOM must be equal. These questions are very tricky type questions, so be careful while doing these questions, right? So for finding that, what let's do it for the left hand side, right? We can write P1 is equal to P2, right? So for the left hand side, what we can write? We can write for the 25 centimeter, right? So 25, that is the height, right? Height, that is rho. Now H, rho G, rho we have to take, rho will be rho density of water into G, right? Any doubt here? Plus what? Plus some amount of mercury is also there, right? So we are taking at this much level. Can you see here? We have taken at this level. This level we are taking. So now H1 into Hg, that is mercury, that is rho, and mercury we are taking it as H, right? So here into what we are going to do? Mercury we are taking it as H, and then again we can take it as G also, right? Now that will be equal to, right? So I have just little bit space left, so I'm just going to the right hand side. You can observe that what I can write for the right hand side, right? Right hand side, you will see that 27.5 into, that is density of the spirit will come here, right? Into G, plus again H2 will be coming, right? H2 into density of the mercury into again G comes, right? So basically our intention is to find H2 minus H1, because from there only we are going to see the height difference, right? H2 minus H1 we need to do. So how you will do H2 minus H1? Keep all things at other side, right? So you are going to get, ultimately you are going to get 25 into rho W, right? Minus 25, that is 27.5 into rho spirit, divided by what? Divided by, you are going to get rho of H, that is mercury. Got it? Now you'll ask me how where G goes. G will be cut down from both the sides, right? Getting my point. So if G get cut down from both the sides, right, you need to find the height difference, right? So what you can put it here, you can put the values, right? So after putting the value 25 into, that is density of the water. Density of the water is how much? Just now we have done, right? That is density of the water. We can get it around, right? So what we can see? See density of the this one, and that is density of mercury is given. Can you see here? Basically, what is the difference of the level of mercury? Specific gravity of mercury is given. So specific gravity means what? Gravity, that is we consider with the help of the water, right? So we have just got the values, right? That is specific gravity of what? Specific gravity, if you want to find, that is density of the spirit, right? So it will be what? 0.8 into density of water. And just now we have seen the density of the water. We have taken it what? We have taken a density of water as 1000, right? Because just now we have done the question, correct? So what we can take? We can take 1000, right? So here it will be 0.8 into 1000 you can do, right? So for that, what you are going to do, because you can put the value here, density of water, take it 1000. Now here that is 27.5 into density of the solid, that, sorry, density of the spirit, that is 0.8 into 1000, correct? 0 0.8 into 1000 you can do. By what? By mercury, right? Mercury density is what? So mercury density is again, that is they have given, right? So how much they have given? That is 13.6. 13.6 again 1000 will come here, right? 1000, 1000, 1000, 1000 will getting cancel out, right? So if you just multiply, right, you are going to get at the last you are going to get 0.22 centimeter, right? So this is what about the height difference. I hope you understood my point, right? So this is about the height difference.